Okay, so let's get right into it. There's a new algorithm out there called TurboQuant, and it's really starting to shake things up in the AI world. Now, on the surface, it looks like a simple story about making things more efficient. But the real story? It's this wild economic paradox that's turning the whole market on its head.
So this is the big question, the one that really spooked the market at first. And it makes sense, right? I mean, if you can suddenly do way more with less, you'd think you'd just buy less. If your car suddenly got twice the gas mileage, you'd probably buy less gas. Seems pretty logical.
And this is where things get really, really interesting. That first knee-jerk reaction, that simple logic, it completely missed the bigger picture. We're about to break down exactly why that assumption was wrong and what's really going on. All right, so to really get the economic twist, we first have to understand the technology itself. What in the world is this TurboQuant algorithm that's causing such a stir? To put it simply, TurboQuant is a super smart way to shrink the data that AI models need to work with. And in doing that, it directly attacks one of the single biggest headaches in modern AI, what's called the memory bottleneck. Think of it like a massive traffic jam on a highway, where the processor is just sitting there waiting for data that can't get to it fast enough.
So how effective is it? Well, the first number to lock in your brain is 6. TurboQuant can slash the amount of memory an AI system needs by a factor of about 6. That's not a small improvement. That's a massive leap in efficiency.
And okay, saving all that memory is great, but what does it do for performance? Get this, it can speed up the whole process by up to 8 times. So you've got this 1-2 punch. AI operations become way more efficient and dramatically faster.
Now, this is a really important point to clear up. You don't go out and buy TurboQuant. It isn't a piece of software or some subscription service. It's much deeper than that. Think of it more like a fundamental standard, kind of like JPEG for images or MP3 for music. It's a core recipe, a piece of infrastructure that gets built into the systems themselves.
And this brings us right back to that central paradox. With these absolutely incredible gains, what is the real fallout for the hardware industry that AI is built on? Let's finally connect the tech to the economics.
The answer, believe it or not, lies in this really counterintuitive idea from all the way back in the 19th century. It's called the Jevons paradox, and it explains this whole situation perfectly.
So the Jevons paradox basically says that when you make a resource dramatically more efficient and therefore way cheaper to use, people don't just use less of it. Instead, that low cost opens up so many new possibilities that total consumption actually goes up. The classic example was with coal and steam engines. As engines got more efficient, they didn't use less coal, the world just built way more engines and ended up burning more coal than ever. And we're seeing that exact same pattern play out right now with AI.
And this breaks it down beautifully. Step 1. TurboQuant makes running any AI task much, much cheaper. Step 2. Because it's suddenly so affordable, companies start using AI for everything, for all sorts of new tasks they couldn't justify before. And that leads to step 3. This absolute explosion in usage creates so much new demand that the total need for chips and hardware actually goes up, not down.
Okay, so that's the theory. Let's look at how this paradox is actually playing out in the real world. What was the market's initial reaction, and what does the long-term reality actually look like for some of the biggest players? Let's start with the memory chip makers, the giants like Samsung, SK Hynix, and Micron. The short-term fear was totally understandable. Wait, if every AI model needs 6 times less memory, we're going to sell less memory. But the long-term reality, thanks to our friend the Jevons paradox, is the complete opposite. Because AI is now so cheap to run, it's going to be deployed everywhere, on your phone, in your car, in every single business process. But total number of AI tasks is going to skyrocket, which means the overall demand for their chips is actually going to be much, much bigger. So who are the clear winners in all this? Well, you can see 4 big groups. First up, the cloud providers, your Googles, Microsofts, and Amazons. Their costs plummet, which means their profit margins go up and they can scale like crazy. Second, any company that adopts AI can now afford to automate way more of their business. Third, and this is a big one, is edge hardware. Think Apple or HP. Suddenly, powerful AI can run right on your phone or laptop, not just in some distant data center. And finally, the entire ecosystem of AI agents gets a massive boost because the cost of running them just fell through the floor. When you zoom out, TurboQuant isn't just about saving a few bucks. It really signals a fundamental change in how AI is going to develop over the next 10 years. And this rollout's going to happen in waves. We're in that early deployment phase right now.
But look ahead a few years to 2027 or 2028, and this will probably be a standard, built-in feature for all the cloud services. By the end of the decade, it'll just be there, invisible but everywhere, powering everything under the hood.
So here's the bottom line. Before, if you wanted bigger, better AI, the answer was always a brute force one. Just throw more hardware at the problem. More chips, more memory. The whole game was hardware bound. But now, the focus is shifting. Scaling is going to depend on smarter algorithms, on being more efficient. We are entering an era of algorithm-driven AI growth.
And if there's just one thing you take away from all this, let it be this quote. The true power of something like TurboQuant isn't just making the AI we have today a little bit better. It's about unlocking AI so it can be integrated into nearly every part of our digital lives. So the real question this leaves us with is, once the cost of intelligence gets close to zero, what becomes possible?